Hi learners, good morning to one and all. Myself Dr. E.K. Mohanraj as a Professor and Dean Civil Engineering from Nandha Engineering College, Erode. Today we discuss about the course Strength of Materials, and as you are all aware about that, Strength of Materials is one of the important core subjects for civil engineering, and it is not only for the civil engineering, it is also important to the other branches like mechanical engineering, mechatronics, as well as chemical engineering. And in the mechanical engineering, the subject name is called strength of material, and in civil engineering we normally thought it is under two courses like mechanics of solids 1 and 2, and in chemical engineering we name it as a solid mechanics. And in that strength of materials, the one of the important unit or otherwise called as a module is called as a beam. Now today we discuss about the important topic, that beam. How the beams are classified and what do you mean by that beam? Beam is an horizontal structural member which is normally rest on the two pillars or otherwise called as a column, and whatever the load received from the beam is normally taken from the roof slab, and from the roof slab the load is received from beam, and from the beam the load is distributed to the two supports, both left hand side support as well as right hand support, through the columns, and it is transferred to the soil or otherwise called as a foundation. So the beams are normally classified as a 6 types of beams as per our module or syllabus. That is nothing but cantilever beams, simply supported beams, and overhanging beam, and propped cantilever beam, as well as fixed beam and continuous beam. And as you know that overhanging beam is subclassified into another two types. One is called as an one side overhanging beam, another one is called as an double side overhanging beam. And this propped beam is subclassified into two types. One is called as propped cantilever beam as well as propped simply supported beam. And this different types of beam is classified based upon the supports. Normally supports are classified into three types. One is called as roller support, another one is called as an hinged support, and third one is nothing but fixed support. And these supports are based upon the reactions, and roller support can carry only one reactions, that is in vertical alone, and hinged support can carry both vertical reactions and as well as horizontal reactions. And in the fixed support, normally there are three reactions. It will consider both horizontal reaction, vertical reaction, as well as moment. So based upon these reactions, the different types of beams are classified. And according to these 6 types of beams, the first 3 types of beams are classified as a statically determinate beams. And remaining 3 types of beams are classified as statically indeterminate beams. How this statically determinate and indeterminate are classified is based upon these support reactions. And normally we know that cantilever beam is an fixed at one end and other end is free. So this cantilever beam consists of one end is fixed, means there are 3 unknowns. And similarly for simply supported beam, the one end is an hinged support and another end is an roller support. Therefore the simply supported beam is also an totally 3 unknowns, and overhanging beam is also under the same conditions of like a simply supported beam. One end is hinged, another one is roller. So these 3 types of beams are under the category of statically determinate beams, because these 3 types of beams are 3 unknowns. Normally if the beams are with 3 unknowns only, that is sigma v equal to 0 and sigma h equal to 0 and sigma m equal to 0, and you know that these 3 equilibrium equations are called as sum of all vertical forces equal to 0, sum of all horizontal forces equal to 0, and sum of all moments equal to 0. So if any beam, to find out the reactions and solve the beam by using these 3 equilibrium equation, then the beams are treated as are classified as statically determinate beams. If the beams are not sufficient to solve these equations alone, then the beam is treated as statically indeterminate beams. That is, these three types of beams are more than three unknowns. Because of proper cantilever beam, one end of the beam is fixed with left hand support and another right support is an hinged or an roller support. Therefore, it is an more than three unknowns. Similarly, for fixed beam, both the supports are an fixed end. Therefore, totally has an 6 unknowns. And the continuous beam is nothing but, that is the beam which support more than 2 supports. Therefore, it is equivalent to more than 5 or 6 unknowns. Therefore, these three types of beams are classified under the category of statically indeterminate beams. Therefore, these statically indeterminate beams are not sufficient to solve by using these equilibrium equations alone. Therefore, it is under the heading of, in addition to this, some of the equations are necessary to solve this type of beams. So, today we discuss about the different types of beams, and under the different types of beams, we will solve the problem from one by one. First, we will go through with cantilever beams. Now, we discuss about the problems in cantilever beam. Cantilever beam is nothing but it is fixed at one end and the other end is free. So, here an example for one cantilever beam with a 3 meter span of 3 point loads. One 4 kilonewton load is acting at extreme free end, then another 3 kilonewton point load is acting at 1 meter distance from the right support, then third load 2 kilonewton load is acting at 1 meter from the left end. Of each point load at a distance of 1 meter frequently, then as a first step, to find out the reactions of this given cantilever beam, and in a cantilever beam, the left end A is an fixed one, there is, so we have to find out the reaction at the end A, and B is an no support. If there is no support, there is no reactions as well as no bending moment acting at the point B because of the no supports. Therefore, to find the total vertical load, that total vertical is nothing is but the summation of the all vertical load is equivalent to total reactions at the point A, that is equivalent to 9 kilonewton, and that all external loads are acting in downward direction. Therefore, the reaction A is acting in the upward direction, that is RA, that is reaction at the support A, that is of total 9 kilonewton. So, after that we have to find out the or plot the safe force diagram. That safe force diagram is nothing but SFD, and we will plot the baseline in a horizontal one. Then we start the safe force diagram from the extreme left end. From the extreme left end, this upward kilonewton 9 kilonewton acting in upward direction. Therefore, you put the upward line, and from A to C there is no point load is acting. Therefore, put the horizontal line. Then at the point C, 2 kilonewton acting in downward direction. So, you plot accordingly. If any upward load forces is acting, you just draw in upward direction, and if any downward loads are acting, then plot in downward direction. Accordingly, this safe force diagram is starting from the point A, and it is in upward direction, and from A to C there is no loading, and 2 kilonewton is acting in downward direction. Then from C to D there is no load is acting. If there is no load is acting, then you maintain the horizontal line. At the point D, it is in 3 kilonewton in downward direction. Then from D to B there is an horizontal line, and at the point B, as a 4 kilonewton load is acting in downward direction. So, this diagram is nothing but safe force diagram, and if any diagram plot above the baseline, then it is called as a positive diagram, and below the baseline, then the diagram is treated as a negative diagram. Accordingly, the safe force values at various points, that is A, B, C, D is written like that. The safe force at A is nothing but 9 kilonewton, then the B is nothing but 4 kilonewton, and at the point C there is a variation between left hand side of C as well as right hand side of C. So, if you consider the left hand side of C, this 9 kilonewton load is acting, and if you consider the right side of the C, that is 7 kilonewton is acting. Therefore, we mentioned as in left hand side it is 9 kilonewton and in right hand side it is 7 kilonewton. Similarly, at the point D also there is a chance to find out the safe force value at these 2 points, both left hand side as well as right hand side. So if you consider the left hand side of D, it is on 7 kilonewton, and right hand side of D, it is on 4 kilonewton. So all these values are in above the baseline, therefore these values are in positive shear force value. Once if you write the shear force value, we have to find out the bending moment. Bending moment is nothing but the point load is acting with distance. The multiplication of both point load as well as distance is nothing but bending moment, and shear force is nothing but only consider the loads, external loads alone. Therefore the unit value of the shear force is normally in kilonewton, and the bending moment load is considered as a kilonewton and in meter, the units for this bending moment. So we consider the bending moment at the point B. Bending moment at B is nothing but here there is no support, therefore without any support the moment or reaction is not considered, therefore the bending moment at B is 0. Similarly for bending moment at D, bending moment, if you consider the any point the bending moment values, you consider the right side of the beam, that is 4 kilonewton, and the distance is nothing but 1 meter. Why you put negative sign at here? Here it is a very important one. If you consider the upward direction any forces, then we will use the positive sign, and if you use the downward forces, then we consider this one as a -1. Therefore this bending moment at D is 4 kilonewton meter. Similarly for C, once again you consider the extreme right side of the beam, this -4 kilonewton into 2 meter, similarly -3 kilonewton into 1. So totally the bending moment value at C is -11 kilonewton meter. And at the last point, the bending moment at the point A, here A is an fixed support and extreme left end for all the cantilever beams. This A is the fixed one, and the maximum bending moment occur at the fixed end. So you consider all the three loads into corresponding distance, then we will get -20 kilonewton. Based upon these values, we will plot this bending moment diagram. Once again, we consider the same baseline, and all the values we got it in a negative manner. Therefore, we plot accordingly in a negative direction. That is at the point B, it is 0. Similarly, at the point D, the bending moment values is -4 kilonewton meter, and the bending moment value of C is -11 kilonewton, and at the point A, it is 20 kilonewton meter. If you connect all this point, then we will get the bending moment diagram for this given cantilever beam. And here you connect by using this inclined line because of this point load, and this is the shear force diagram and bending moment diagram of the given cantilever beam.